My name is Nur Nadira binti Anwar. Today I would like to talk about direct titration. What is direct titration? Direct titration involves adding a known solution to an unknown solution until the reaction is complete. By measuring the volume of the known solution needed, we can calculate the concentration of the unknown solution. Direct titration, also known as simple titration, it is a common method used in analytical chemistry to determine the concentration of an unknown substance which is analyzed by reacting it with a standard solution of a known concentration which is titrant. The titrant is carefully added to the analyte until the reaction between the two is complete, as indicated by a specific endpoint. The endpoint can be determined by observing a change in color, pH, conductivity, or other measurable properties of the reaction mixture. Direct titration is widely used because it is relatively simple and straightforward. The purpose of direct titration is to determine the concentration of an analyte in a sample by carefully measuring the volume of the titrant solution required to react completely with the analyte. It is possible to calculate the concentration of the analyte based on the stoichiometry of the reaction. Direct titration is used in various fields, including pharmaceuticals, environmental analysis, food testing, and many other areas of chemical analysis. It allows researchers and analysts to quantify the amount of a particular substance present in a sample, which is crucial for quality control, research, and regulatory compliance.
Basic component of titration. The first one is titrant or standard solution, which is reagent. It is a liquid of known molarity or normality that is added to the sample or liquid in need of measuring. It will react with the analyte. Reagent is usually placed in a burette and slowly added to analyte and indicator mixture. The amount of the reagent used is recorded when the indicator causes a change in the color of the solution. The second one is titrant or analyte. It is the sample or liquid in need of measuring and being analyzed. The solution with an unknown molarity. It is mixed with a small amount of indicator. What is indicator? Indicator is a small amount of a compound that changes the color of a solution based on the pH level in the solution. The useful indicator has a strong color that changes quickly near its pKa, so that only a small amount of an indicator is needed. If a large amount of indicator is used, the indicator will affect the component pH and lower the accuracy of the experiment. The indicator should also have a pKa value near to the pH titration's endpoint. It will reduce error because the color change occurs sharply during the endpoint where the pH spike and give more precise endpoint. The common indicator is panasonic indicator. The third one, which is calibrated device, which is a device of dispensing the titrant drop by drop into the titrant. It is used to deliver precise amount of liquid. The main equipment is calibrated burette. The standard solution is to put it into a burette. When the titration reaches an endpoint, the amount of titrant is recorded and used to calculate the unknown concentration. This is the apparatus that we need to put it. The successful titration, which is the colorless solution, turns into pinkish or purplish color after added the titrant. That's all.
What is acid rain? Acid rain is any type of precipitation that contains acidic elements such as sulfuric or nitric acid that falls to the ground from the atmosphere in wet or dry forms is referred to as acid rain and also known as acid deposition. For example, rain, snow, fog, hail or even dust that is acidic. Besides that, acid rain typically has a pH between 4.2 and 4.4, whereas normal rain has a pH of 5.6 and is just mildly acidic. Next, we move to the causes of acid rain. So basically, acid rain will happen when sulfur dioxide and nitrogen oxide were released into the atmosphere and carried by wind and air. Human activities can be the main cause of acid rain. The first one is burning of fossil fuels. The major chemicals that cause acid rain are nitrogen oxide and sulfur dioxide. Fossil fuels, mainly coal and oil, are used in many aspects of daily life, including energy production, home heating, cooking, and more. These two gases are massively released into the atmosphere through the burning of fossil fuels. On burning, coal and oil release pollutants such as sulfur dioxide and nitrogen oxide. When these gases are released into the air, they react with the water molecules in the atmosphere to produce mild sulfuric and nitric acid. Since burning coal and oil release a huge amount of sulfur dioxide and nitrogen oxide gases, these are mainly compounds of acid rain. Besides, industrial activities also one of the causes of acid rain. The level of nitrogen oxide and sulfur dioxide in the atmosphere is also increased by manufacturing industry, including those that produce chemicals, cement and other goods. To reduce the amount of nitrogen oxide and sulfur dioxide release, this industry have begun using technology. However, even when the emission level has decreased, a long-term continuous process will still result in acid rain sources. Last, vehicles and heavy equipment. Vehicles are major contributors to the atmosphere release of nitrogen oxide and sulfur dioxide. Today, as the number of cars, trucks, and other large pieces of equipment has greatly expanded, so has pollution. Because of the high pollution levels in urban areas, acid rain is frequently seen there.
Simple mechanism of acid rain. Acid rain results when sulfur dioxide and nitrogen oxide are emitted into the atmosphere and transported by wind and air currents. The sulfur dioxide and nitrogen oxide react with water, oxygen, and other chemicals to form sulfuric and nitric acid. This then will mix with water and other materials before falling to the ground as an acid rain. Wind can blow sulfur dioxide and nitrogen oxide over long distances and across borders, making acid rain a problem for everyone, and it will kill plant life, pollute rivers and streams, and erode stonework. Going to the effect of acid rain. First, it can damage to vegetation. Acid rain can harm vegetation including trees, crops and plants. The acid deposition weakens the plant's overall health, harms the leaves and prevents their growth. Second, aquatic ecosystem impact. Water bodies become more acidic when acid rain enters them and lowering the pH. Fish, amphibians and numerous invertebrates that live in aquatic environments may suffer as a result of this change in acidity. It can lead to population losses or local extinctions by interfering with their reproductive cycles and harming their gills. Third, damage to buildings and infrastructure. Buildings, monuments, bridges, and other construction forms of materials can corrode and degrade due to the acidic elements in acid rain. And lastly, fourth, human health. Inhaling sulfur dioxide and nitrogen oxide can worsen pre-existing cardiovascular disorders and lead to respiratory issues including asthma and bronchitis. As we can see in this slide, this is the method to titrate acid rain. First, acidity in water can be determined by titration with sodium hydroxide to an accepted pH level between 7 and 10.5. Second, usually a pH of 8.3 is used, and metacresol is employed as an indicator. And fourth, ppm or of its calcium carbonate equivalent can be used to express the acidity of water, which can be translated to pH. And this is the expected outcome of the investigation of acid rain. The arrow shows from right to the left. It shows that it's more acidic. To sum up, direct titration is the most basic titration which is commonly used. In this type, a titration of known concentration and volume is added to a substance in order to analyze it. Direct titration usually used in daily life. Titration is not just an experiment you need to perform to pass chemistry in school. It has many important applications in everyday life. For instance, a food processing company might use titration to calculate the precise amount of salt in a particular foodstuffs. It can also be used to determine the concentration of vitamin C or vitamin E additives in foods. These factors not only determine the taste and nutritional value of the food products but can also affect the aesthetic of them. For example, the concentration of additives directly impacts the overall color of a food product. So it shows that direct titration has many important applications in our daily life that we can use it. So that's all from us. Thank you.